The present solar theory depends on the belief that matter and gravity are inextricably bound together, that one always determines the amount of the other. However, if nature allows for gravity to be created with less mass, then observations that have been at odds with present models start to fall into place. But how can you have more gravity with less mass? That's what this video is all about. Our concept of the gravity and mass relationship is so ingrained in the sciences of our contemporary civilization that it's become the natural starting point for any endeavor in astronomy and cosmology, with very little scope for alternatives. Indeed, faith in this belief structure is not without good cause. Every experiment with solids, liquids, and gas in any combination gives us every confirmation that this is the nature of things, that any theoretical consideration of solar interior should rest on a foundation in the belief that matter and gravity are synonymous with one another, that the relationship between substance and resulting force are an inviolate bond, that if you have X amount of mass, you must have X amount of gravity. And so, the gravity-mass relationship is at the root of any standard solar hydrogen fusion core modeling. A large body of mass is gravitationally pulled into a ball. The amount of matter is so great that the gravitational pressures allow for fusion reactions to occur in the central core, and the radiation from this energy source is released, working its way outwards until it reaches the photosphere, where it issues forth to produce light and radiation that we observe. This is essentially the solar model that has been standard since the 1950s. But all is not well. Ever since the inception of the core model, a gradual store of observations have accrued that decidedly do not conform to this model. Taken individually, these disparate sets of data can be rationalized, set aside as curious anomalies, observations that are eventually expected to be explained and incorporated into the solar hydrogen fusion core model at some future date. But when taken as a sum, these seemingly small contradictory observations build a picture completely at odds with the present solar model, so much so as to make it untenable. So let us briefly examine these observations.